All right, guys, welcome to How to Perform Deck Inspections course. I am Andy Kushak. I am the market leader for Buyers Protection Group. I cover Southern Missouri, Arkansas, and Oklahoma. I had previously had my own company and then merged in with BPG about a year ago, and it's been great. But I've had I ran my inspection company for 10 years, and before that, I was in commercial construction, and before that, I was in residential construction. Um, this course specifically, I actually have used a lot of this information from this course. I do construction litigation courses also, so I do investigations, and over half of the cases that I've taken on for litigation have been deck related. So again, you'll see a couple of my reports at the end of this course that had gone to litigation, and every case that I've taken to litigation has either settled for the benefit of the client or was a judgment in favor of my client. So some really good reports and stuff that you should see at the end of this that are in relation to decks. Um, all right. So this course teaches the inspector to perform residential wood deck inspections according to the InterNACHI home inspection standards of practice. It includes a review of common deck defects. This course references standards and code, but home inspectors are not code inspectors. So just to hit this right off the bat is there is a lot of code that we're going to talk about today. Obviously, we are not code inspectors, but it's important to know the code references so you know what you're looking at. So, if you know that the lag bolts in a ledger board are incorrectly spaced, you look at that ledger board and there's a huge crack going down the middle, you know that there's probably, the anchor bolts are probably not either undersized, they've been bored too large, a whole host of things. But knowing those code references will help you to inspect, your homes and provide valuable information to the client and to maybe the contractor too. All right, here we go. Oh. So more than 2 million decks are built and replaced each year in North America. Uh, InterNACHI estimates that of the 45 million existing decks, only 40% are completely safe. Because decks appear to be simple to build, many people do not realize that decks are, in fact, structures that need to be designed adequately to resist certain stresses. Like any other house or building, a deck must be designed to support the weight of people, snow loads, and objects. A deck must be able to resist lateral and uplift loads that can act on the deck as a result of wind or seismic activity. I'm going to close this real quick. Okay. Oh, sorry. I closed my wrong window. All right. Um, Deck stairs must be safe and handrails graspable. Deck rails should be safe for children by having proper infill spacing. Rail failure occurs much more frequently than total deck collapses. However, because rail failures are less dramatic than total collapses and normally don't result in death, injuries from rail failures are rarely reported. The home inspection standards of practice. So in the exterior portion of the standards, the highlighted sections are specifically can relate to to decks. So inspector shall inspect the exterior wall covering materials and how it integrates with the deck ledger, flashing and trim and how it integrates with the deck, stairs, stoops, stairways, and ramps, porches, patios, decks, balconies, and carports, railings, guards, and handrails, and the improper spacing between intermediate balusters, spindles, and rails. Decks and similar structures. So there are lots of exterior structures that are related to or similar to a deck. They include verandas, balconies, patios, porches, stoops, those types of things. It's important really to know the difference between all of these so that when you put when you're writing the comments in your report, you're using the correct terminology, so that everybody knows what you're talking about. If you're, I'm going to be kind of blunt here, but if you're, saying a veranda is a patio and a patio is a veranda, there's a lot of mixed communication that can happen, and can cause, stress and issues and stuff like that with realtors and with your client. So just make sure that you're using the correct terminology when you're referencing anything in a home inspection report. Deck load. A deck inspection should progress in much the same order as deck construction. Inspectors should start at the bottom. If a deck is deemed unsafe from underneath, the inspector should not walk out onto the deck to inspect the decking, handrails, etc. The inspector should stop and report the safety issues, and then what is visually observable from a safe location, and then that's it. You've done your job at that point. The IRC provides design tables for decks up to 10 pounds per square foot dead load and 40 pounds per square foot live load. Most decks are designed and built for loads of 40 to 60 pounds per square foot. The 2021 IRC includes snow loads for 50, 60, and 70 pounds per square foot. Just refer to 2021 IRC R301.2. A 40 pounds per square foot live load is equivalent to a 200-pound person standing in every 2.5 foot by 2 foot area on the deck. That's a lot of people standing near each other on the deck. Stairways must also support this load, but in addition must support a concentrated load. Hot tubs are common on decks, but they provide a significant concentrated dead load. Hot tubs filled with water and people are heavy and can weigh a couple of tons. Hot tubs require framing that can support more than 100 pounds per square foot. Engineered or alternative designs for supporting a hot tub may be necessary, but may be handled with an over-design in the joist and beam sizing, spacing, or spans. Deck footings are sometimes not visible during a home inspection. Deck structures that are attached to the house should be supported on concrete footings or other approved structural systems. Deck footings should be sized on average 3 times the size of the post. You can refer to the 2021 IRC R507.3 for those requirements. I will say the 3 times the size is just a rule of thumb. What actually goes into calculating that is the tributary area. So how much of the support post is supporting the deck, the deck flooring and the joists and all that kind of stuff. So it's going to vary widely, but as a general rule of thumb, you want 3 times the size of your support post. Footings are not required for freestanding decks with joists directly supported on the ground over the entire length of the joist. Footings are not required for a freestanding deck that has one, the joist bearing directly on precast concrete pier blocks at grade without support by beams or posts, a deck not larger than 200 square feet, or a walking surface is not more than 20 inches above grade at any point within 36 inches measured horizontally from the edge. The settlement of soil located below a deck can pull the deck away from the ledger attached to the house. A freestanding deck is not attached to the house. The illustration you can see to the left there. The illustration shows a freestanding deck with one of its posts resting on disturbed soil. A deck post should not be installed on disturbed soil, and disturbed soil can often be found next to the foundation of a newly built house. The top right illustration depicts the 7-foot rule. On steep properties, the slope of the ground around the footing could affect the footing stability. The 7-foot rule states that there should be at least 7 feet between the bottom of the footing and daylight. Obviously, you're just going to have to take a rough measurement of those things, but that's really a good indicator. If you're unfamiliar, there is a term in engineering called the cone of compression. So let me see if I can do annotate. All right, so where the bottom of this footing is over here, you have what's called the cone of compression. So as the earth around here angles out, This is the earth that relies on this footing. So just like the footing is sloped out, not all footings are going to be sloped out like this, but as this footing sloped out, the cone of compression starts at the edge of the footing and goes outward, so that as the pressure from the vertical load pushes down, everything is kind of compacting down, and you have the earth that is going to, the earth is present that will support that footing. So oftentimes what you're going to see, and you'll see this later in the class, where you have a sprinkler system or downspouts or whatever, and they terminate right next to a deck footing or a deck support post. And over time, the erosion can occur and can slowly take the earth away from that footing. So, if you ever, you're going up to a deck and the footing is exposed and you can see underneath that footing, which is very common on steep slopes, um, then you want to call that out, or you want to at least look at the structure and make sure that nothing is moving, nothing is racking one way or the other, so on and so forth. So you just, want to make sure everything is in line, everything's supported correctly. Um, let's see here. Oh, how do I get rid of that? Annotate. There we go. Oftentimes, too, you will see this guy, this precast concrete pier. So, in my area, they sell these at Lowe's and Home Depot, and um, you get some willing, some eager, younger contractors who want to start their own business, want to start a deck building business or whatever. And, they watch some DIY channels or whatever. And so they go to Lowe's and they pick up these guys thinking that these are actual footings, but these are not footings. These precast concrete piers are generally for when you have those decks that are low to the ground. So that's why these notches are here, so that you can run a, you know, a joist or a beam, and it can notch in between these guys. Again, these a lot of times are incorrectly used as footings, so you'll see these resting directly on top of the ground. They're not dug in. There's no drainage base in there, anything like that. So, in these instances where this is resting directly on the ground and you have an actual deck that is built on top of it, maybe it's a two-story deck or a deck higher than 20 inches off the ground, and you see these, this is going to cause, as the moisture in the ground changes throughout the year, and you put these kind of precast footings on top of the ground, it's going to change the elevation of the deck. So the deck might not be level, it might not be plumb. It can start to, rack or get out of plumb, out of level, just because the footing has not been dug down, below your frost levels. And even when we're talking about frost levels in my area, we don't have a frost level, but our minimum footing depth is 12 inches deep by 12 inches wide and 6 inches thick. So if the precast, whatever, if they're using a precast, if it does not meet those same qualifications, then it is not a footing and it is not correctly installed. So pay special attention to those decks and make sure that they are, supporting like they're supposed to be supporting. The bottom of the deck post must be restrained to prevent lateral displacement. Um, the lateral restraint may be provided by a minimum post to footing connection based on the manufacturer's requirements for connections supplying lateral restraint, or by embedding the post at least 12 inches into the soil or concrete piers. Posts in contact with soil should be pressure treated. You can refer to the 2021 IRC 507.4.1 for that. Posts should be connected to their footing so that the posts don't lift or slip off. Often, the bottoms of the stringer boards or deck stairs have been found to rest on soil, concrete block or rock, as opposed to resting on posts installed below the frost line. Posts set on soil are subject to rot and movement due to moisture. Posts that are set in unsound footings may cause movement and make the deck above unstable. Um, all right, let me bounce out of that. See if I can move this without, I cannot. All right, try this. All right. All right, high decks. So the image depicts a high deck being supported with a four by 4 inch post. Tall 4 by 4 post twist under load, and 4 by 4 post, even when treated, decay below grade too quickly. Oh, let me hold on a second. My marks are still on here. Let me clear those. Clear all drawings. Perfect. As a general rule, for all but the lowest of decks, deck posts should be at least 6 by 6 and be no higher than 12 feet. 14 feet is acceptable if cross bracing is used and the posts are 8 by 8. Posts that are 4 by 4 can be used for heights up to 14 feet, but only under certain circumstances. Moisture and wood decay, as we were talking previously. Wood can decay and degrade over time with exposure to the elements. Decay is a problem that worsens with time. Members within the deck frame that have decayed may no longer be able to perform the function for which they were installed. Paint can hide decay from an inspector and so should be noted in the report. Inspectors should know that painted deck posts can hide and cover wood decay. As wood ages, it is common for cracks to develop. Large cracks, longer than the depth of the member, or excessive cracking overall can weaken deck framing. Toe-nailed connections are always at risk of splitting. Splitting of lumber near connections should be noted by the inspector. Um, it was very common in my area to only toenail deck joists for, I mean, we still see it in newer construction today. Generally, our AHJ inspectors, our city and county inspectors, don't generally inspect decks. I mean, they're getting more stringent about decks, so that it's happening more often, but that's only in the last, I don't know, 5 to 10 years. So most decks, or I would say not most decks, but a lot of decks in my area, pre 10 years ago, are not built correctly. Everything is toe-nailed. There's no joist hangers. There's no blocking. There's missing ledger flashing. The mounting hardware is incorrect where they're using screws and nails to attach instead of half-inch lag bolts or half-inch lag screws. In our area, like I would say, most of our decks are not built correctly, and so we find a lot of issues with decks, even on new construction. And again, make sure, if there are gutters and downspouts that are terminating close to the house or sprinklers that are near the deck, then pay special attention. Do your pick test, which we're going to talk here in a minute about what a pick test is. Um, but, um, you know, again, we often find where the downspouts have caused erosion underneath footings, or when you get like this middle picture right here, when they first installed the deck post and the footing, and then they backfilled it, it might have been level. It might even been crowned at the time that it was installed. But as that loose fill dirt, it wasn't really that compacted, and as it settles over time, it actually creates like a little concave area around the deck post, and that can start to hold water against the post or against the footing, and can start to cause deterioration there too. So oftentimes when I find deck posts that go directly into the ground, I'll pull the dirt back just an inch or so around, or if there's rock around there, pull it back a little bit, and then use my pick test or use my awl to see, if the posts are rotted, and that's a really good indicator for maybe how long they've been there, especially if you have those older decks. You'll find that a lot. And then I'm going to go back a picture here too. Oh, let me go back. So this precast concrete pier in the middle, um, when that is used as a deck support post, or a footing for a support post. Let me get my annotator out here. So this area right here really likes to hold water. And so as it rains, that water goes down, and it gets into the end grain of the wood. Well, the end grain, if you think about this as a tree, this the grain in the wood, it's intended to draw moisture up. And so, when you get water that sits there and then, uh, maybe it's angled back or, whatever the case is, but it holds water, it starts to draw water up, and then that happens over and over and over again. It draws up, dries out, draws up, dries out, and you get dry rot over time, or, or just rot. So pay special attention to those areas if you do see these precast footings, and a lot of times they are notched, kind of like this one is. Pay special attention to those areas, and if it's rotted, if it's defective at all, that's a good observation to call out in your report. All right, so back to the rest of this. Let me get rid of my drawings, get rid of that, and then we'll get back. All right. So the pick test. The pick test, it uses an ice pick, awl, or screwdriver to penetrate the wood surface. After penetrating the wood, the tool is leveraged to pry up a splinter parallel to the grain away from the surface. The appearance and sound of the action is used to detect decay. The inspector should first try the pick test in an area where the wood is known to be sound to determine a control for the rest of the inspection. Decayed wood will break directly over the tool with a few splinters and less or almost no audible noise compared to sound wood. The pick test cannot detect decay far from the surface of the wood. Um, so whether you're using this on your support posts or on your joists or whatever, a pick test is very, very useful in determining the quality of the wood or the age of the wood or the deterioration of the wood, obviously. Girders and beams. So untreated joists should be at least 18 inches away from the ground. Girders and beam ply should be 12 inches away from the ground. However, in many situations, exceptions are made where the elevation of the home does not provide for these minimum distances and the climate is very dry. Beam plies should be fastened together with 2 rows of 10D 3-inch nails at a minimum of 16-inch on center along each edge. You can reference the 2021 IRC table 507. R 507.5 for those numbers. So again, this stuff that you're going to find very common, which we still find, is where you surface attached. You're not notching, or there's no blocking to support the girders. And a lot of times these are nailed too, and not even bolts or screw or I'm sorry, lag bolts or through bolts. So again, that's another reason why 4x4 posts are not can no longer be used, because when you're installing a girder, it has to be notched in and resting on the post. What will happen over time is, and when you have a connection like this where it's surface mounted, water will travel in between this washer and or the bolt or the screw, and over time, because you have exposed the grain inside the wood, as water seeps into there, it'll soak into the wood, and then it slowly rots out around that mounting connection, and then you start to lose structural support, and it starts to sag. It can start to crack off of the corners. So anytime you're seeing anything that's surface mounted like this, just pay special attention to those mounting locations, to cracking, anything where the weight of the joists are going this way. And over time, with that weight and with that rot, it can start to sag. Uh, you can start to sag down. Can you notch a 4x4 post so only 2 inches are left for the beam to bear on? No, because in order for a notch to meet safety standards, you have to have 2/3 of the post left. So because if you only leave 2 inches, it's very likely, which you're going to see a picture at the very end of this report, where they notched a 4x4 post and it cracked down the side because there was not enough structure left in that post. So ideally, you never notch a 4x4 post. Um, And that's why you should always size up to a minimum of 6 by 6. Like I said, the remainder of the notch post. So when you notch a 6 by 6 post, um, well, the remainder should be at least 2 inches thick. But again, uh, so yeah, I'm thinking because it's an inch and a half, right? Anyway, um, ideally, the new code, new IRC code says that you should never notch a 4 by 4 post. Leave it at that. All right. And then making sure that you always have your structural connections here. So what you'll see down in this bottom left with a girder is a lot of times you'll just see toenailing and to attach the beam to the support post. You want positive connections, either mechanical or blocking or whatever. But because what a lot of times what will happen is as the load of the deck, again, you're having the joist go this way. As people are standing on this deck, they're moving around. You're getting a lot of back and forth, going back and forth. And if you don't have a really strong connection at the post, you can start to rock that beam back and forth, and it will start to pull the nails out. From that girder from the support post. So again, very, very important to have really good connections between your beams and your support posts. Clear drawings. All right. Let's see. Let me see if I cannot figure out how to advance that with the annotation still on. All right. Um, all right. There's a few diagrams here. The illustrations depict a butt joint or a splice, the top left over here. The butt joints are splice improperly located within a girder span. Butt joints in a girder span are generally not permitted unless specially engineered. A butt joint or splice should be positioned to land at the posts. Notches in solid lumber joists and beams must not be greater than 1/6 the depth, must not be longer than 1/3 the depth, and must not be located in the middle 1/3 of the span. You can see this, all of that in this diagram to the bottom left. Um, the tension side or the bottom side of a beam's 4 inches or greater in nominal thickness must not be notched except at the ends of the beams. The diameter of holes bored or cut into joists or beams must not exceed 1/3 the depth. Holes must not be closer than 2 inches to the top or bottom of the joist or beam or to any. Oh, I'm sorry. You know what? That is actually incorrect. So holes must not be closer than 2 inches to the top of the joist, but can be within 3/4 of an inch to the bottom. That is a brand new code change that just happened in this last code cycle. And mainly that is because, you know, uh, the the pressure is pushing down. You're more concerned with having more structural integrity at the top of that joist than you are at the bottom. We need to update that diagram. So the let's see the to the right. The illustration depicts a level being used to check for beam sag. Even with a carpenter's level, it can be difficult to see beam sag from the front. The image depicts beam sag being eyed up. Often it is easier to detect beam sag by the eye than with the level by looking along the bottom edge of the beam. Um, if there is beam sag, most of the time, what you'll see, if it's bad enough, you'll see uplift here on this corner and on this corner over here. You can kind of see it in the diagram a little bit. But if this is severely sagging, which you should be able to eye it, but one of the first indicators that you should look for is the gap where all the pressure is being put on this corner, where you'll start to get crushing off of this corner here, and you'll have a gap on the other side over here. Not all the time, but a lot of times that's what you'll start to see. All right, clear all drawings. And where are we at on time? So we're 30 minutes in. Great. Go to next. Ledger connections. The most common cause of deck collapse is when a ledger pulls away from the band joist of the homes and buildings. The two most common ways to correctly attach a ledger to a structure are with lag screws or through bolts and washers. The installation of through bolts requires access to the back side of the rim joist, which in some cases is not possible without significant removal of drywall within the structure. Determining the exact required spacing for the ledger fasteners is based on many factors, and so is beyond the scope of a visual inspection. But for your general knowledge, assume a deck is built with a 40 pounds per square foot live load design. The joists span 10 feet and half-inch diameter lag screws with washers are used. The on-center spacing of fasteners is then 18 inches. The tip of the lag screw should fully extend through and beyond the inside surface of the band joist. InterNACHI's ledger fastener spacing formula provides inspectors with this general rule of thumb. On-center ledger spacing of half-inch lag screws with washers in inches equals 190 divided by the joist span in feet. And then on-center ledger spacing of half-inch bolts with washers in inches equals 330 divided by joist span in feet. But this is just a very general rule of thumb that may differ considerably from modern building standards practices and local residential code. Lag screws or bolts must have washers and be installed through the ledger board in a two-row staggered uh, staggered pattern. So where was I go? Staggered from the top and the bottom along the horizontal run of the deck ledger. What you'll see and what you're going to see in my report pictures later on is where people love contractors that are not in the know love to space the fasteners in line with each other. So instead of staggered, they will do in line. And then what happens is that you put two bolt holes here, and it's very easy to run, to get a crack coming off of here, to get a lot of cracking. So you basically, you've lessened the structural integrity when your bolt spacing is on top of each other. Um, Yeah, the placement of lag screws or bolts at the deck ledger board should be 2 inches from the top edge, 3/4 inches from the bottom edge, and 2 to 5 inches from the ends. So that's correct. I don't know where we got that other information from. All right, let me see. Let's get out of here. All right. Oh, and let me clear my. Oh, delete all drawings. Okay. Band joists supporting a ledger must be a minimum 2-inch nominal solid sawn lumber or a minimum inch nominal engineered wood rim boards. Refer to the 2021 IRC R502.1.7. The tips of the lag screws must fully extend beyond the inside of the band joist. The IRC also states that deck joists that connect to the side of a deck beam or ledger board must be supported by approved joist hangers. Deck ledgers should be made of at least 2x8 pressure treated wood. The illustration depicts a floor joist resting on a 2x2 inch ledger strip. That is the left side, and then you have another one where they notched in, and then you have your joist hangers. And then obviously in this picture, we are actually incorrect on our spacing here for our bolts. And this is a picture I took in the top right corner. So not only do you have joist hangers, a ledger strip, you also have what we call blocking in between the joists. So what a contractor will do is that they'll put this blocking up right here. Sorry, they'll put that blocking up, and then they nail into that blocking, and then the blocking is then nailed into the ledger, and the same thing from the other side. So basically this is one piece now, right? And that's terrible drawings, but I bet. So this is basically one piece now, and then it attaches. So Uh, so you'll have, those four different kinds of connections between ours, and they still install this blocking in deck construction today. So, um, which I've never really seen any issues with this type of construction. So, I have seen issues with this ledger strip because why they don't allow ledger strips in new construction anymore is a lot of times these ledger strips they're so small that they soak in moisture really easy and they can start to deteriorate really fast. Um, you lose because a lot of times they're just nailed through into the ledger. And those nail penetrations, they will start to rot out. So this ledger strip really is, if you do see this ledger strip in construction, pay special attention to that component because most of the time it's pulling away or it's rotted or whatever. The two really only connections I see in modern construction anymore are the blocking and the joist hangers. Now, a word about joist hangers. So here are three different sizes of joist hangers, right? Um, Interestingly enough, so this one is rated for a 2x8 or a 2x6. This one is rated for a 2x8 or a 2x10. And this one is rated for a 2x10 or a 2x12 or 2x14. So if you're looking, so this is a 2x10. And so, um, if you're looking at the sizing and you want to make sure that your joists, your hangers are the correct size for the board. Honestly, what you should do is look up the model number on the bottom of this. You probably can't see this, but there is a model number. There should be a model number on every joist hanger. And so if you're concerned about the joist sizing being incorrect, look at the bottom. Look up the model number. It'll tell you what it's rated for. Because while this one, you can see that you have an inch and a half, 2 inches there. Um, so that one looks correct, but this one is also rated for a 2x10, and it can look small and can kind of throw you off. You're like, oh, that is too small for that joist. But again, make sure that you're looking up the model number to see if it complies with its manufacturer's installation instructions. All right. Oh, and before I forget to, here are your half-inch lag screws and your half-inch lag bolts. Um, I'll get to your guys' questions here at the break. So we'll give us and I'll answer those. So we got about another 10 minutes or so. Um, again, your through bolts, you want to make sure there's a washer on both sides. You should, if there is a through bolt, you should be able to see both sides, both the head and the threads. And again, you want to make sure that you don't want the nut barely hanging on by a thread or two. The nut should be fully seated on the threads, and then making sure that you have washers on both sides. So. Um, and then if you're concerned about, say you're looking around a ledger, uh, and you have a bolt there, I would go and tap some of them. If they shake or you can hear a ringing in them or they move at all, try, go a little bit further and see, can it pull out? A lot of times, these things, as people use the deck, as with anything, everything vibrates. And so, which it can vibrate the nut loose, or if the connection point through the ledger has rotted away because moisture is getting in there, it's an older deck, and you lose connection on these, through the lag screws or through the lag bolts. So you can hit them with a hammer and see, and you can uh, find one that is solid, that is connected, hit it with a hammer, see what it sounds like, and then you can go through and use that as a baseline and test the rest of them. But again, if there's any movement in these at all, then likely it needs to be addressed or corrected. Because this, obviously these are what is holding the deck to the house, and that is the structural integrity. All right, so let me clear drawings. Um, Okay, and then I know you guys are probably talking about. Oh, I know. If I were to look at this picture, you would say, "Look, hey, they attached the ledger board directly to the brick veneer." Obviously, that was definitely a call out, but this is the best picture I could get with the blocking. So we definitely called that out, and you can see that there's no lag bolts. They're not staggered, and so I believe they attached these with nails. I think to the brick veneer. So this was definitely a call out as being structurally inadequate, but did not show any damage. So that's up to you on how you want to dictate that on the report. If you even call it out at all, if there's no damage associated, but that's how you should evaluate, the house is it damaged? If it is damaged, what's causing that damage? If it's not damaged, it's your call on if you want to go above and beyond and call out structural inadequacies in your report. But that's up to you. All right, get out of here. Clear drawings. All right. 10 more minutes. I'll answer these questions and we'll take a break. Um, all right, again, so this joist should be fully resting on their joist hangers, and joists must be cut long enough to reach the ledger or the band joist that's supporting them. Where you're going to see issues like the diagram on the left is um, which the whole reason why we use joist hangers now is to prevent this issue on the left hand side where somebody installed a deck, they used a ledger strip, the deck starts to dry out and age, because the most of the time pressure treated wood is very green, it's very wet, and so as the deck dries out over the next 2 years, it can start to shrink and it can start to pull off of the ledger strip. So that's why, we have gone to joist hangers, is because you create a positive connection by the nail holes. So if you look at the diagram on the bottom right, while this one is not correct, the joist hangers are a good picture where you have the nail holes that attach the joist, and then you have the mounting hardware on the post, and that creates all that positive connection that keeps everything sucked into each other. Now, and again, you'll see picture this later at the end of this presentation, where maybe they set the joist hangers first, and then they incorrectly measured or whatever, and the joists do not seat in the joist hanger. So that is definitely an issue. It needs to be called out. Because you're lacking the support that is intended by the joist hangers. So make sure that the joist hangers are resting in your joist hanger, or the joists are resting in the joist hanger. All right. Ledger board and band joist contact. So the image depicts a ledger board and band joist sandwiching the structural sheathing. Sheathing is permitted to be wood, structural panel, gypsum board, fiber board, lumber, or foam sheathing. The 2021 IRC for ledger connections allows up to a 1 inch of open space between the house band and the ledger. This provides for wall sheathing and/or drainage and ventilation. It is not intended for cladding. Many, many times you will find where they have sandwiched the cladding, and I would say most of the time it's either brick veneer. Um, I don't. I rarely have ever. I don't know if I've ever seen stone veneer where a deck has been attached to it, but it's not impossible. But brick veneer is definitely adhered to, and vinyl is definitely adhered to, and stucco is definitely adhered to. Um, Anytime you see a wall cladding like that, it was they definitely missed the mark because the wall cladding is not structural, but when you attach a structural component to and through it, it now becomes structural. And a lot of times at those connections or on that band joist around those, you'll see cracking if it's masonry composite or made of masonry, whether it be brick veneer or stucco, or block or whatever, you'll see cracking. I'm sorry, not block, but you'll see cracking coming off of through those connection points. Up to a half-inch thickness of stacked washers is permitted to substitute for up to a half-inch of allowable sheathing thickness when combined with wood structural panel or lumber sheathing. Oh, not the right function. Oh, not the right function. Codes in some areas outright forbid attaching a ledger board to open web floor trusses. Um, so I've never seen a ledger board directly attached to open web floor trusses, but I have seen manufactured eye joists that were used as the band joist for the house. Um, but what they had to do is because, when you attach your dimensional wood and your through bolts and your lag screws, and it goes through a manufactured eye joist, all that is plywood, or OSB, and it is not with that gap, because a lot of times, you have a half inch gap or a half inch, yeah, gap between the webbing in the middle and I can't remember what the name of that, but the top chord of that manufactured eye joist. And so that's not structural. And so what they'll do is they'll slide in a piece of either dimensional wood or um, like a manufactured beam. I can't think of the technical term for it right now, but a manufactured beam, and they'll put that in there, and then when they attach the ledger board through to that then becomes structural. So if you go into a crawl space and you see that you have manufactured eye joists and you have a deck that is clearly attached to the outside, if you can, pay very close attention to where that ledger board is, to where the band joist is, and especially if it was used or if the band joist is a manufactured eye joist. And then if it is, make sure that there is some type of some structural addition that is in between the eye joist and the exterior sheathing. All right. All right. The image depicts a ledger board improperly supported by brick veneer, so the top right diagram. Deck ledgers are not permitted to be supported on stone or masonry veneer. You will see it all the time. We see it on new construction all the time. You're going to find, I mean, you can almost guarantee that if it is a brick veneer house, that is, I mean, it could be any story, brick veneer, but almost always you're going to find where they have attached directly through. Now, where there could be where you don't have enough knowledge to be able to make a specific statement is when the brick veneer is, it's veneered over masonry block. So definitely if the brick veneer is over framing, that is 100% not allowed, right? But if the brick veneer is directly against masonry block, not necessarily masonry block or poured concrete, you're not able to see through the block wall to see if it is mortared or if it's been filled with concrete. If it's, if the brick, or you don't know how long the bolts are, any of those types of things. So in those instances where the ledger board is attached to stone, I'm sorry, not stone, but poured concrete or block wall, if you can see the inside of that foundation, I mean, you probably won't if it's an elevated slab, obviously, but if there's a crawl space and there's a block wall or concrete, and you should be able to see something, right? Or do your best to investigate as much as you can. And then if you can't see you can't see any of that stuff, look for damage, look for defects, look for cracking, and then, call out what you see and any potential issues. And let them know. Let your clients know that you are limited in your ability to see inside the block wall, but your recommendation is this, and just go from there. So ledger boards should not be attached directly or surface mounted to stucco or eaves. stucco and eaves have to be cut back so the ledger boards can be attached directly to the band joist. However, cut back stucco and eaves are difficult to flash and weatherproof. All right, let's take a 10-minute break and I'm going to answer some of these questions. AJ?
You got it.
All right. Stephen Caddy, can you use 4x4 and place a 2x4 on the face of one side from the footing level to the beam and place the beam on that 2x4? Um, when it comes to installation, non-standard installation, so you can do a lot of things. I mean, there's a lot of, so before I got into inspecting, before I actually got into actual working for residential and commercial construction companies, my dad and I remodeled houses together. And my dad and I had never read a code book. We almost never read installation instructions. So we were one of the many contractors that I now would call out, things on, right? But we always were sure to over-engineer everything. I mean, our mantra was we want to drive a Mack truck on it. That was my dad had told me that since I could remember, and I've started to use that, in my terminology and stuff. So as long as, the way that you engineer stuff, as long as you over engineer it and you make sure that everything is supported, or when you're inspecting something, it might not be to standard or it might not be to code, but if it is working as intended, it's engineered, it's over engineered, everything is being supported, then a lot of times, for me personally, you guys do what you want, but I don't call out those as issues or defects. If I can tell that something has been over-engineered and has been working for 20 years, there's no rot, there's no defects, there's no cracking, there's nothing going on with it, then I leave it alone and I say it's good. I don't, you know, it, there, you know, if there is a potential issue in the future, I would probably call that out. But if I don't feel like there is going to be an issue in the future, and everything is working as intended, then I call it good. So, as far as being able to use a 4x4 to put a 2x4 on the face of it, and then put beams and stuff on top of it, if it is over-engineered where there's all kinds of mounting hardware, everything is properly protected from rain and ice and snow, uh, and there's no way to know if it's going to meet code standard or if it's going to meet structural standards. But if it's going to work, if it works as intended, then for me, I would call it good. Uh, Paul Hutt, we always use the rule of thumb: the joist hanger has to be larger than half of the depth of the joist. Um, Yeah, that's a you know that using these as an example, that's a really good indicator, because this one is not rated for 2x10. Well, here, let me show you this though. So even though this joist hanger is rated for 6 inches or 8 inches, we're right at halfway between this. So um, as that rule of thumb, you may qualify this one, but it is technically not rated for a 2x10. Um, but it's up to you guys on how you want to do it. If it's operating as intended, if again, if they have put so many beams and support posts and all that kind of stuff, and maybe the joist hanger is just a formality where the most of the load is on the beams, is on the correctly sized support posts and all that kind of stuff. If the joist hanger is undersized, it might not really matter. So again, if do your due diligence, do your best, and if you want to call out things as being undersized but still working, that's your guys' call. Um, oh, What do you say when you see joist hangers secured with screws? So here's the thing with screws and nails. I have found through litigation, through my litigation investigations, there are screws that are structurally that are what do I say are acceptable in joist hanger connection. Now, I will say, uh, Simpson Strong Tie, which is who makes most of our connections for joists. Um, if you read their installation instructions, they make the hardware that goes into these guys. And so they reference pretty much their own hardware should go into these. And most of the time, they are nails, right? But there are screws that are structural in nature that do have a shear rating. So as long as the screw has a shear rating that matches what Simpson Strong Tie requires for shear rating, that their nails adhere to that shear rating. If they are above and beyond that shear rating, I would say I would not be a problem. The problem though is you really will never know if they have a shear rating. Most of the time, even if you pulled that screw out, the markings, the indicators on there, unless you know the brand and the model, you're not going to know if it has a shear rating or not. So if you're doing the installation yourself, and you know that the screws that you got have a shear rating, they're at or above what Simpson Strong Tie recommends, absolutely use them all day long. Um, just know that if you come across if you go to sell your house, or you're building a house, an inspector like one of us comes along and they see a screw in there, they don't know if it has a shear rating. So they might call it out as not, as needing to be updated or changed or verified or whatever. So again, do do whatever you feel is necessary, but know that there might be questions that come up later from, either selling the property or a buyer or whatever it comes to. So here's the brick veneer. Here's your concrete wall. Obviously, we have these wedge anchors that were used. That's really all you can use in wedge anchors. Again, I'll show you a picture at the end where a client used, or I'm sorry, a contractor used wedge anchors in a block wall that were not filled, and then they ended up cracking the block wall through the connection because the wedge anchor did what it was supposed to do. So if you've never seen a wedge anchor, the wedge anchor goes in, and as you tighten, the back end spreads out, puts a lot of pressure so that the wedge cannot come back through. So if you do have a block wall, uh, hopefully you're able to see the inside of that, either from the crawl space, or a lot of times we have, you know, well, if we have like a walkout basement, this is the situation, like the the report that I did, it was a walkout basement. They had a block wall foundation. The contractor, he used wedge anchors. So I was able to, they had a drop ceiling in that walkout basement. So I was able to pop a tile and look in and saw that none of the cells were filled with concrete. And we were able to use that in our case against the contractor that they did not use the correct mounting hardware for the super important structural ledger board. If you do, it is possible to use bolts in a block wall, but then you have to use an approved um, acrylic or what it looks. And I don't know if you've ever seen it, but there's a glass tube. So if you get a specific anchor that can go in a block wall, and it comes with a glass tube that has and like an expanding type foam or acrylic in it. So you put that tube in the hole that is drilled, then you put your screw in. It breaks the glass tube in there. The chemicals mix together and it hardens and basically creates like a wedge on the back side of that block that should stop it from pulling back through. Um, you'll almost never be able to know or see that. So unless you see a box or some type of um, case or something like that that's on site, or the leftover installation instructions or whatever. All right. Ledger board flashing. This is one of the most commonly incorrect portions of new modern construction. We see it I saw it on a multi-million-dollar house where they did not put ledger flashing in, and I'll tell you the reason. Oh, well, so there was this two-story house with a crawl, or I'm sorry, it did not have a crawl space, but it was a two-story house, but it was on a hill, and the contractor stated that they did not put ledger flashing in because it was a covered deck. So basically, they just put a little roof over the top of it. Now, that might protect the interior portions of the ledger board, but on the end portions of the ledger board, they are still exposed. And so you still get rain that gets, wind driven, or if, whatever rain or whatever angle the rain is coming from can still get in and behind, uh, you know, uh, behind the ledger board when there is no flashing in it. So, unfortunately, our area right here is growing so fast that even though I called that out, I provided all the InterNACHI diagrams, I provided the code references, I did everything. The builder still refused because we are in a seller's market, or we were. We're not so much anymore, but we were in a seller's market. So the even though I provided all the details, whatever, the client still bought the house, but then they hired their own contractor to come in, and they took up this deck board here, and then they slid up their own flashing. They could not install the bottom flashing over the bottom here, but they were at least able to get the top flashing in. So you do your job, you point out your things, and then let the client do whatever they want with it from there. Okay, so ledger flashing is intended to divert moisture away from the wooden components of the house. A deck ledger connection is only as strong as the wood it is attached to, and rotted wood is not strong at all. The ledger flashing is only required for decks attached to wood frame construction. Since the ledger board is required to be decay resistant, the flashing functions primarily to protect the house. Ledger boards attached to concrete foundations do not require this type of flashing, and a durable sealant see here. There we go. And a durable sealant is recommended in these applications. So you can see that here. Would they have the caulking installed here, and they have the caulking installed here. So there's no because this is not a moisture sensitive material, concrete and block wall. That's why you don't have to have flashing that goes over the ledger board here. You really want caulking because you don't want if water is allowed to be trapped. Let me back up. So we all know that water likes to travel, and especially when you have a tight space, water will travel through that tight space because of I can't remember the function that uh, the the capillary effect. It has the capillary effect where it will draw through in a tight space. So if you put that caulking there, that sealant there, that will help deter water from being drawn into here and then being potentially drawn into the mounting holes or even trapped in between this wood. And again, if that water is allowed to be trapped in there and maybe it's a little looser up here, and so there's a bigger gap, and it's really tight down here. Well, now that water has less of a chance of draining out from behind here. So you want to stop as much water from getting in between the ledger board and the block wall or the concrete wall as much as you can. All right. Um, So the illustration that you can see here depicts the flashing installed over and under the ledger board. The ledger board should be flashed even if the home has protective roof overhang. Aluminum flashing is commonly available but should not be used. Contact with pressure treated wood or galvanized fasteners can lead to rapid corrosion of the aluminum. I wish I had a picture of this, but if you ever go up to a deck and you can just see the flash, they installed flashing, and the flashing looks like it's just falling apart or it's rusted or rotted. A lot of times it's aluminum, and it's rusting like that because it is in contact with the chemical in the pressure treated wood. Um, so it's really hard to tell if it's brand new, if it's aluminum or not. Obviously, I think you can, if you have a magnet with you, you could probably test it that way. But most of us don't carry magnets with us for that function. But definitely if it's deteriorated, that's a no-brainer. Call it out every time. Um, and then in my area, almost never will we see under ledger flashing. Uh, Even on the most high-end homes, I think I've come across under ledger flashing maybe twice out of 6,000 plus homes. And so but the most important flashing is going to be this one. I mean, this one is also important. And if I were to build a house today, I would put both flashings in, especially if I have a framed basement wall or framed walkout basement area or whatever. You definitely want to protect that because I don't know if you guys can even see my mouse, but here, let me get my annotator out. Um, but you're creating a shingle effect with the flashing so that any water that comes down is going to be directed out and away from the house. So this water drips off here, comes back, drips onto the ledger board, and then again with that capillary effect, it has the potential, if this flashing is not here, to be drawn underneath the ledger board and then come back into the wall structure down here. So um, best practice, always see that, but like I said, I never see it, and I don't even call it out as being missing. Now, if I'm doing an investigation, for a litigation or whatever, I will call it out. But on a standard home inspection, I don't call out missing under ledger flashing. Um, let's see. Content. Okay, so that's so aluminum and the flashings. Okay, I think. That's everything on this one. All right, let me clear my let me clear my drawings and we'll get on to the next. All right, overhangs. So band joists attached by a ledger must be fully supported by a wall or the sill plate below. Many deck failures have been attributed to a cantilevered floor rim joist pulling away from the house or shearing downwards. Band joists are just nailed to the ends of the floor joist. Without any direct support underneath a band joist, the nails alone cannot support the load from the deck that is attached to it by the ledger board. I used to see this in my area in the past where they attached, so this is a correct installation, right? But where they have attached the band joist directly to the bay window or a chimney. It's generally a bay window. Generally, our chimneys go all the way to the ground, uh, but to a bay window, I've seen where they've attached directly instead of framing around it. I think in my, like I said, over 6,000 inspections, I've only called this out twice. Whereas your area might have it more often. It all kind of depends on what the standards were and who taught who, and has bad information been handed down generation after generation, which is very common in construction. In my experience, almost nobody reads installation instructions or the code references. Most of the time, contractors educate each other from what they've been taught and what they've learned over the years, and then information is just handed down. So if bad information, is being handed down again and again, we see defects over and over and over again. That is especially true. This is not a roof class, but I see that especially in roofing, where installation instructions or code is never read, never followed, and bad information is just handed down from roofer to roofer. So, and that same thing is less likely in the licensed trades, so your HVAC, your electrical, and your plumbing. But any non-licensed trades, it's very, very common. So pay special attention to those non-licensed areas and their installation practices. All right. Um, uh, okay. Yeah, keep going here. Oh, God. I keep forgetting to get rid of my annotator. Spans and cantilevers. Calculating spans and cantilevers for deck beams and joists is beyond the scope of a home inspection, but a home inspector should know what is a beam span, a joist span, a cantilever, and how to divide by 4. For joists bearing on a wood beam, at least 1.5 inches of bearing length of the joist is required. So for what we were talking about before, where uh, when we were talking about the 4x4 post being undersized and being able to put a a joist or girder or a beam or whatever on top of it, you must have 1.5 inches of bearing on the joist or on the beam. Sorry. Old rule of thumb, wood deck beams can cantilever at each end up to 1/4 of the actual beam span. That's the old rule of thumb. Joist span does not include any bearing area, but only the space that is not bearing upon the beam. Home inspectors may refer to the old general rule of thumb during a home inspection because home inspectors are not code inspectors and are not required to refer to or quote code, including this information about deck joist cantilevers. Um, all right, let's see here. Yeah, here's more. Okay, good. So you can see here, the illustration shows a deck joist cantilever in front of the deck and the deck beam cantilevers on each side of the deck post. Beams are permitted to cantilever at each end up to 1/4 of the actual beam span. So the beam span divided by 4. The deck joist should be cantilevered according to the 2021 IRC Table 507.6, which is what you see here, for maximum deck joist spans and maximum cantilevers. So if you see here, so in reference to the span table, you have a 40 pounds per square foot live load design. The joist species is spruce pine fir. Again, because the joist species matters in spans and cantilevers, and we'll never be able to know that. So you're just your old rule of thumb. Basically what it comes down to for me is if I can see any drop in that cantilever, I then call that out as an issue. And you can reference the joist span tables and stuff like that. But the what is cantilevered should never drop. There should not be a significant drop from the end of the cantilever to where the support post is. And that's the rule of thumb that I use in my inspections. But anyway, the joist size is a 2 by 10. The allowable joist span is 13 feet and 7 inches, with joist span or space 16 inches on center. So here's your cantilever. Oh, so in this instance, with these dimensions, with this species, your cantilever is 3 feet. And here's what we were talking about earlier about checking your connectors and your fasteners. Um, we'll just be beating a dead horse here, so all that's the same. Uh, Lateral connections. This is fairly new in code. So, I mean, I'm sorry, not new, but the hold down tension devices are fairly new. Oops. So lateral loads shall be transferred to the ground or to a structure capable of transmitting them to the ground. The IRC requires decks supported by the attachment to an exterior wall to be positively anchored to the primary structure and be designed for both vertical and lateral loads. The vertical and lateral loads referred to are code prescribed loads such as dead, live, wind, and seismic loads. Attachment only to the band joist may not be sufficient for lateral loads. Positive anchorage of the deck joist to the house's floor framing, as shown in the left figure, addresses this potential failure. Refer to the IRC 507.9.2. Where lateral load connections are installed at the deck, the inspector should observe hold-down tension devices installed in at least 2 locations per deck, and they should be installed within 24 inches of the end of each end of the deck. For new or replacement decks on existing homes, builders or homeowners must often remove interior wall or ceiling covering in order to install these large hold-down tension devices. Another type of lateral load connection that is permitted to be installed at the deck are surface mounted and should be installed in at least 4 locations per deck, with one at least 24 inches from the end. These devices achieve an acceptable lateral load connection between the deck and the primary structure, i.e. the house, with the installation of these surface-mounted hold-down connection devices that are spread out along the length of the ledger and do not require opening up the interior wall or ceiling spaces nearby. These devices provide a positive connection to the floor framing in order to resist the lateral loads. And so you can see here, uh, hopefully you guys saw that in the eye, but that's what that is. Or you have the large hold down tension device here. And you'll see in this next picture, oh, so these are the old school ways of bracing for lateral loads. So the left image depicts a deck with a post to joist diagonal bracing. Decks greater than 6 feet above grade could have diagonal bracing from post to girder and from post to joist. Diagonal bracing is required in some older building codes that did not require lateral bracing. Deck post bracing that is installed in addition to required lateral bracing is not a defect. The right image depicts a deck with post to girder diagonal bracing. Freestanding decks not supported by the home or the building should have diagonal bracing. The middle illustration depicts the underside diagonal bracing of a deck floor structure. Decks greater than 6 feet above grade could have diagonal bracing across the bottom of the joist to keep the deck square. A deck that is not held square could permit the outer post to lean to the left or to the right, parallel to the ledger board, and thus twist the ledger away from the home or the building. And you'll see that on occasion. Especially when you have 4x4 posts that tend to twist anyway. When those deck posts twist, they pull the whole structure with them. So you want to pay special attention to the 4x4 elevated decks, especially when they don't have diagonal bracing underneath to keep everything square. And we're not doing videos. Guards and supports. Where guards are supported on deck framing, guard loads must be transferred to the deck framing with a continuous load path to the deck joist. The guard must connect to the floor joist, not the outer rim or band joist. That is very important. So uh, let me see here. This used to be how deck railings were installed. So this a lot of times is a 4x4 post. It's then notched and it's attached to the outer band joist. This is no longer acceptable connection, and you'll see why at the end of this class. Um, Very common to get cracking and damage here, and then if any force is put uh, on that railing, a lot of times it'll just snap right off. And then again here, the rot at the connections, the on the through bolts is very common, especially on a 4x4 post. It doesn't take much to rot out that post at all, and then you have loose handrails all around that deck. All right, I lost my space here. Okay, shall be connected to, if the guard is connected along the exterior joist, it must be connected to an adjacent joist. Otherwise, the single joist connection will rotate and won't support the guard above adequately. Connections relying only on fasteners and end grain are not permitted. Where guards are mounted on the top of the decking, the guards must be connected to the deck to transfer the guard loads to the adjacent joists. The right image depicts a notched deck guardrail post attachment. This common notch type of attachment was permitted by older codes, but is no longer acceptable. Newly notched posts are a defect. Notched guard posts, specifically 4x4s. Attachments could become loose and unsafe, especially as the deck ages. Code now requires that connection extend back into the framing in some manner to help prevent a guard from pulling a rim joist off the ends of the joist or from rotating a single side joist. I will say 4x4 posts are still allowed to be handrail or safety railing posts, but they cannot be notched. And most of the time, in order to meet the requirement, it has to be on the inside of the band and attached to the adjacent joist. I'm determined to get really good at annotating, so bear with me. All right. Let's see. While graspable stair handrails are meant to support us and must resist forces in all directions, guards that wrap around a deck are only meant to keep us from falling off the edge. According to the 2021 IRC, guards will no longer be required to resist forces pulling inward or upward, only outward. Leaning on or sitting on top of a guard is common, so it must be able to support the load. Guard and handrail design loads and load direction are separate and different. The concentrated load direction for guards and handrails in the IRC before 21 was all directions. Now it's just outward and downward. So, guards, a concentrated load of 200 pounds per square foot, outward and downward. If the top of a guard is not serving as a required handrail, the single concentrated load could be applied at any point along the top, in the vertically downward direction and in the horizontally outward direction away from the walking surface. Where the top of a guard is serving as the handrail, a single concentrated load could be applied in any direction at any point along the top. So inspectors should really wiggle those handrails. While handrails are graspable and can be pulled in any direction, a guard is not required to be pulled or pushed in any direction, just down and out. A guard has no reason to resist a fall backward or to resist load placed in line or upward. Because of leverage, a 200-pound force pushing the deck's guard outward causes 1,700-pound force at the upper bolt attaching the post. It is difficult to attach deck guard posts in a manner that is strong enough without using deck guard post brackets, like the one you see in the bottom. The middle image depicts a deck guard post. Most codes require guard only around the edges of the deck, 30 inches or higher. Why would a home inspector recommend guards for a lower deck even when recommendation exceeds code requirements? The primary reason centers on safety and liability. While the building code establishes minimum requirements of 30 inches, a professional home inspector's role goes beyond just code compliance to focus on overall safety and risk mitigation. Fall injuries can occur even at lower heights. Home inspectors often make recommendations based on best practices rather than just on the minimum code requirements. So guys, just remember this when we're talking about code. Code is the bare minimum a house can be constructed to. There is leaps and bounds above code, which you can recommend to your clients. But code, and which is so funny, is that when you talk to a contractor, a lot of times they'll be like, "Oh, code, I don't, code, that's not necessary. Code, we shouldn't have to do that or whatever." Code is the bare minimum for construction standards, meaning that if you go below code, you are substandard in your construction. So you definitely want to go above and beyond code, and which most oftentimes that costs more money, and that's most of the time not going to happen. But code is the bare minimum for construction standards. Even industry standards. So when you go like the National Roofing Contractors Association or the National Wood Council or whatever, you read any of their standards, and if that contractor is a member of any of those standards, just like for InterNACHI, InterNACHI has, the highest standard out of the few options in the industry. We as inspectors and as members, as CMIs or CPIs, we are required to be held to InterNACHI standards. Just like the National Roofing Contractors Association, if you go to a roof and there is a roofer on there that has a National Roofing Contractor sticker on this truck, and they are not installing to their standard, then they are out of compliance with their organization. So I use that a lot in my inspections and in my investigations. Is that if you can go on the contractor's website and they say that they're a member of this organization or this organization, if you really want to hold them to their standard, you can go and pull their standards. And if they're not installing to those standards, then they're out of compliance with their organization. Okay. Oh, guard height and openings. Um, so Ladder type guard infill on high decks is prohibited. So basically, if you have anything that creates a way to be able to climb, so what's really popular right now is you have cable railings, you have welded wire railings, all those things which create a horizontal ladder that can allow children to climb. Um, so keep that in mind. So what I put in my reports whenever I see a horizontal railing, cable railing, or whatever, I always put it in there. Look, obviously this was designed this way. This is aesthetic. This is very popular in the industry right now. Just know that this can allow a child to climb and can create a potential fall hazard. So I'm doing my due diligence. I'm putting it in there. It's a safety hazard in my book, and then let the client do what they want. 99.9% of the time, nothing is going to change with that horizontal railing. But just know that you did your part. Same thing. Well, not really the same thing with the horizontal or the vertical uh, balusters or spindles. Infill should not be or should not permit a 4-inch sphere to pass through. And then this is just good construction practice. This bottom right hand is that ideally on a deck, you should never have or try to never have a horizontal surface. It's, like we were talking about with wood, and just with anything, most rot on a that you see on a typical house, whether that be a wood exterior wood trim, window or door trim, window trim, or whatever. That's why we see rot at the bottom of doors, right? Where uh, most of the time those jambs they get installed and then they get painted. So the bottom edge, which is the end grain of that wood, and that wood is intended was uh, uh, was in what I want to say its function was to soak water up, and so that's most of the time why we see rot at the bottom of exterior doors is it's not painted, it's not sealed, it's not pressure treated, and so water drips down the painted area, and then it soaks in the end grain of the unpainted area, and then it does it again and again and again, and you get rot. So kind of the same thing, but from the top down when you're talking about a deck. So you have the end grain is always exposed at the top of the wood post, and you should always angle cut that stuff. It allows water to drain quickly away. Instead, if it's horizontal, it will sit there, it'll soak into the wood, and then, wet, dry, wet, dry, wet, dry, and then you get rot. So, again, most of that would never be something that I would call out unless there was advanced deterioration. But in my own decks and my own construction that I'm going to do, I'm always going to angle cut my top portions of wood. Okay. Board placement. So wood decking should be attached to each supporting member joist with at least two 8D threaded nails or two number 8 wood screws. Um, the ends of deck boards near the chimney or the bay window can extend unsupported up to 6 inches. So here we're talking about like this middle top diagram here. Um, Decking should have an 1/8 inch gap between boards so that puddles don't form. Decking should be staggered so that butt joints don't land on the same joist side by side. Each segment of decking should bear on a minimum of 4 joists. That is a lot. You'll see people, contractors who know any better, they try to use all the scrap wood, use all the wood up that they can so they don't waste money or whatever. And you'll see where they're resting on 3 joists or 2 joists or whatever. 4 joists is the minimum. Inspectors should look for splitting in decking and nail pullout. Aside from the structural issues, nails that have pulled out or lifted up, or screws that are not driven into the deck fully can cause injury to bare feet. Uh, Standard deterioration on any deck of any age, you're almost always going to find stuff like this. Um, Especially when boards have been repaired, you don't want to take out a good board adjacent to a bad board so you can stagger everything correctly. So a lot of times you'll find, where the seams are matching up with each other on a repaired deck, or uh, on a deck is especially aged when they use that product out there. I think it's called redeck or overdeck or whatever. But basically, um, it's a thick, super thick paint. Sometimes it has like sand in it or whatever, so it creates traction or whatever. And and what'll happen is they put that stuff and it's so thick that it actually fills the gaps in between the floorboards. And so then you run into water pooling on top. So an already deteriorated deck is now ponding water on top of it. And most of the time, because of that redeck stuff, you don't see the issues from on top of the deck. But when you look underneath that deck, a lot of times those boards are quickly rotting away because that water is pooling, it's soaking into the wood and not allowing to dry. And you got the tree cover, and then your lack of wind and lack of airflow, and that redeck stuff a lot of times causes that deck to very rapidly deteriorate. So pay special attention to those decks that have had that coating applied to it. Um, all right, let's go to the next one. Here's so the next time you guys get a chance, I really wanted to show this video, but it's long, and if you wanted to see how a deck ledger should be attached, this is a great video. So I would highly encourage you to go to the deck inspection class on the InterNACHI website, find the class, and then go find this video and watch it. It is an excellent video on how ledgers should be installed. Almost never installed this way, but if I'm ever going to build a deck, it's going to be installed in this manner. Handrails. This is another thing that is very commonly not done correctly. So stairs with four or more risers should have a handrail on at least one side. That's common. I think we all know that. Handrail height should be between 34 and 38 inches, measured vertically from the sloped plane adjoining the tread nosing. And many deck handrails improperly consist of 2 by 6 inch lumber or decking. Handrails should be graspable, continuous, and smooth. So we see all the time, even on new construction, you'll see where the 2 by 6 is just laid flat and then everything attached. The issue with that is it's easy to get splinters. It is not graspable. So, and the issue with handrails being graspable is that if you go to fall, you want to be able to curl your fingers around and be able to, both your thumb and your fingers should be able to curl around something. If you have a 2 by 6, you're not curling anything. You're coming up to the top or maybe around the side, but you're missing your thumb attachment. So your hand can still slide down. So if you're falling and you don't have a graspable, your hand can slide down that. And then if you get slivers in the midst of falling, that'll cause you to release your grip. And then it just creates a domino effect of potential safety hazards. So, um, I've had a lot of realtors push back on, it, you know, it's fine. It's contractors push back, realtors push back. They're like, it's not an issue, until you have an older client or a younger child or whatever. And that's really what these codes and most codes, safety codes, are designed for. Standard able-bodied people, while still have the potential for safety, what you're really concerned is older and younger people, and those are the people that really need these graspable handrails to be installed. And then here's a quick story on a handrail like this. While this one is not too concerning, well, the handrail should always return back. But the reason why this became an issue um, was mainly because if you fall, and this actually happened when I was in the third grade. A friend of mine, so I was in a school, so this was a commercial installation, and this still happened. This handrail actually extended past the steps. And there was a student in my class, and we were going up these steps. I think we were going on stage to do whatever, and he was talking, and he was facing me. And when he turned to go up the stairs, and he kind of went to run up the stairs, and that handrail stuck him right in the chest and caused some internal organ damage. And so that's why handrails now have to be returned, not only for structural integrity, but for personal safety. So, and handrails cannot extend past um, the main guardrail post. So, mhm. All right, all right. Let me get rid of this. All right, here's just some good description of graspable handrails. Um, so this one. I don't see this one on the right very often, but it does give a way for your fingers to grasp around, and then your thumb on pressure. You should be able to stop yourself from sliding. And then this one, obviously, you have the ability to grasp your thumb around on both of these. But that's why it's limited to an inch and a half to 2 inches, is so that if you measure your palm, you have probably about 2 inches there, so that your palm rests on the top and your fingers grasp around the sides. I will say most older decks, you're not going to have anything graspable at all. Uh, it's up to you on how you want to detail that out to your client. For me, on older decks, I just, tell the buyer, hey, I recommend this for upgrade for a graspable railing. I don't make a big deal about it because older decks cannot be held to new standards. I mean, you can recommend it for safety and whatever, but me personally, I don't make a big deal about it, but I definitely recommend it for upgrade. All right. Yeah. Okay. Stair handrail should have a post at most every 5 feet. And then in general, your stringer should not be longer than 6 feet without being supported. Now, that can vary a lot depending on um, the size of the stringer, how it's constructed, and all that kind of stuff. But in general, I'm looking for 6 feet between on the stringer and 5 feet between posts. If you go more than 5 feet between posts, your handrail gets really wobbly. So just keep an eye on that. If there is more than 5 feet and the stringer is longer than 6 feet or whatever, as long as there's no bowing, there's no flex, there's no movement, nothing's bouncy. Like when you're walking up the stairs, it's not bouncing on you. It's up to you on what you'd want to call out. But for me personally, I don't make a big deal about it. Like I said, if it's working as intended, it's maybe over-engineered, everything's working like it's supposed to, then I call it good. But it's up to you on how you want to go above and beyond. Open risers should not allow the passage of a sphere 4 inches in diameter. On stairs with total rise of 30 inches or less, the size of the open riser is not limited. Uh, Horizontal guards at raised floor areas, balconies, and porches. I got 10 minutes. We'll go on a break. Let's see. Porches should have intermediate rails or ornamental enclosures that do not allow a passage of a 4-inch diameter sphere. The triangular area formed by a tread, riser, and guard should not allow the passage of a sphere 6 inches in diameter. And then the opening at guards on the sides of stair treads should not allow the passage of a sphere 4 3/8 inch in diameter. Um, you know, and all of that is to make sure. I don't know if you guys have ever seen the picture of the kid getting his head stuck, through a railing or whatever, but that's primarily what that's for. You want to limit the opportunity for kids to do what kids do, and they like to test their limits. So if they feel like they can shimmy their way through a handrail or a guardrail, they might try. Kids, are very active, love to climb. I know I found my daughter on top of my chain link fence one time. I found her on top of her little dollhouse. They just love to get into high spaces and see things from a different perspective. And if going through a handrail or a guardrail will do that for them, then they will surely try. So that's why we call those things out. Um, Receptacle requirements. The receptacle should be located no more than 6 feet 6 inches above the balcony, deck, or porch surface. Any dwelling unit with direct access to the ground level must have an outdoor receptacle at both the front and the back of the house. A receptacle that is part of a yard light on a post, for instance, does not meet this requirement. If the dwelling has a balcony or deck accessible only through a door from the inside, an outdoor receptacle located on the balcony or deck may not fulfill the requirement if it cannot be accessed from ground level. However, if the receptacle is within 6.5 feet from the ground and can be reached while standing on the ground, it can be counted as the required receptacle. To protect people, GFCI protection must be installed at all 125 through 250 volt receptacles installed outdoors and supplied by single phase branch circuit rated 150 volts or less to ground must have GFCI protection. All exterior receptacles should be GFCI protected except for de-icing. All right. All that to say is what they don't want is they don't want somebody uh, who is on the ground to run a cable over the deck railing. Um, it's a safety hazard if you need to quickly disconnect, whatever, there's all kinds of issues that could, so that's what they don't want. If it's accessible from the ground, great. If it's not accessible from the ground, then there has to be multiple outlets, right? But the deck should have at least one outlet because both, you don't want a cord hanging from the ground and over, or you don't want a cord hanging from the balcony and over. Uh, And they need to be weatherproofed. So in an uncovered locations, it must be waterproof, where it has a cover over the top of it. If it is covered, then it just has to have the doors, right? The not weather resistant versus weatherproof. Service drop clearance. Overhead electrical service conductors that is connected to the house must be at least 3 feet horizontally from the edge of the deck. When overhead electrical service conductors are within 3 feet horizontally from the edge of the deck, they must be at least 10 feet above the walking surface of the deck. Sometimes the inspector will inspect a new house and the service cable may meet the code on that day by being 12 feet above the backyard, but then a new deck will be built later under that cable and the clearance is reduced to a hazardous inadequate light. So again, like most things, most of the time, uh, when you find issues like that, it's because something was installed after the original construction. So just keep that in mind that if you go to an older house or a new house that, like they said, it will have a deck inspect later, you could, go above and beyond and, take your measurements and do whatever you need or recommend to the client that they verify, that there are specific clearances once the deck is installed, so on and so forth. Uh, Location and egress. So Uh, again, kind of decks built after the house has been installed. So I have found many a septic tank that have been installed underneath the deck. Um, it's just, that's the only place that they could build a deck. They absolutely wanted a deck, so they built the deck over the septic tank. Um, so decks should not be located where they might obstruct septic tank access, underground fuel storage tanks, wellheads, or buried power lines. The right image depicts a deck obstructing a basement bedroom's emergency egress window. The path of egress should not be obstructed by infill or lattice. Basements, habitable attics, and every sleeping room must have at least one operable emergency escape and rescue opening. Where basements contain at least one sleeping room, an emergency escape and rescue opening is required in each sleeping room. Emergency escape and rescue openings installed under decks, porches, cantilevers must be fully openable and provide a path at least 36 inches in height and 36 inches in width to a yard or courtyard so you can crawl out. A deck at the required egress door must not be more than 1.5 inches lower than the top of the threshold. It is common for a deck to be attached to the rear of a house and at a non-egress exterior door. As long as the non-egress exterior door swings open to the inside, the deck outside the door can be up to 7.75 inches from below the top of the door's threshold. Dropping the deck down a step from the exterior door works well because that provides space for a properly installed seal between the door and the exterior wall covering siding or cladding. The drop down step also provides a space above the ledger for flashing behind the exterior wall covering, but dropping the deck down a step may make it difficult to securely line up the deck ledger with the house floor framing band, or rim joist to create a secure lateral attachment. Just real quick note, I have seen a deck installed over a septic tank that was then and then the pool was installed over so basically in this situation right here on the left-hand side with this diagram, and then there was a pool right next, an above ground pool right next to it. So unfortunately, that septic tank was toast, but uh, there's a lot of issues with that house. Um, okay. Termination clearances of mechanical of venting systems. Uh, so as with any combustion systems, you want your combustion vent to meet minimum clearances. Most of the time, when it in relation to a deck, it does not factor in the deck. So you're going to find where um, uh, water heater exhausts, HVAC exhausts, whatever, will terminate directly under, like it'll terminate right outside the exterior wall, and then which is right directly under the deck. There is no requirement for it to be extended anywhere. Now, what I tell my clients is that if you have, and most of the time uh, it's like high efficiency, so it's a PVC vent or whatever. Um, where it terminates out. Otherwise, you would have to, have clearances where it goes, you know, uh, far enough away from your windows and your doors and stuff. But where you have those exhausts that are terminating directly under the vent, I just tell my clients, hey, if you have noxious gases, if you smell exhaust fumes or whatever, you can always extend the exhaust out past the deck. It's going to look a little weird, and it might not meet the requirement, the length requirement for the HVAC. You would have to contact an HVAC person or a plumber so that to see what the furthest distance you can get it away from underneath the deck is. But I just tell my clients, if you smell the exhaust fumes at all, just call the appropriate contractor and ask them if they can reroute it to a different location. Um,
And dude, we can take a break.
oh, perfect. Yeah. All right, I will let me answer these questions then. So, perfect. That was right on time. So, Christopher Park, for a brick veneer wood framed house, would you call out the Simpson strong tie anchors that are designed for brick veneer? Um, So, I honestly I would have to read the installation instructions. And see, because I've never. I'm going to be very honest with you. I don't know if I've ever seen those anchors in the field in real life. So, for me to give an accurate response to that, I would probably just read the installation instructions and see what they said. A lot of times, people take uh, like if it says Simpson strong tie anchors for brick veneer, and then they just take that at face value. But a lot of times in those installation instructions, there are specific requirements in those things where, they require certain distances or, just certain requirements. And so for that installation, I would I would just have to read the installation instructions and make sure that it adheres to at least the bare minimum installation instructions. If the spacing needs to be closer, or if the spacing is closer out, which exceeds past the installation instructions, then I would be happy to see that. But again, um, all right, Raymond Zink, thank you for mentioning the need for lower deck fall protection. Absolutely. Um, Yeah, so what Raymond was talking about, he said he thanked me for mentioning the lower decks needing guardrails. And you know, I was in college at one time, I've been to many a house party, and so if you have a deck really of any height and you have a group of people on it and they're having some adult beverages and somebody takes a step back, if the deck is between 20 and 30 inches off of the ground, at the very least, you'll twist an ankle, Obviously, again, the code is bare minimum. You can always go above and beyond code. So if you feel like your client needs to have that extra protection, by all means, call that out. So you're very welcome. And then, all right, Raymond, I would love send me an email. You can send an email to, and I'll send you if anybody wants to contact me in the future for any questions, you can reach me at admin@tradexuniversity.org. And I would be happy to discuss anything with you. .org. And I'll put that in the chat too, unless you guys can see it. Okay. So Kristen Ernst. In regards to deck handrails, do you suggest that inspectors call out handrails that do not have a return as a safety issue? I haven't seen any that do have a return, but your story is convincing. In new construction, I call it out as a safety issue. In older construction, you could, again, it's one of those things you can recommend for upgrade. I'm not, for me, when I recommend for upgrade, I try to not put that observation on the seller. If we're doing a home inspection for a transaction, anything I'm recommending for upgrade, I'm not recommending it to be done by the seller. I'm recommending it to be done by the buyer. The house met standards. Likely. So when I'm recommending for something for upgrade, usually that observation I'm identifying was built to the minimum standard when it was constructed. But obviously, things have changed in construction. Standards have changed, materials have changed. And so, if I'm recommending for upgrade, it's because maybe the new standard is in place and it had related to safety. And so, I'll upgrade it for that. So, but like, we all have a summary page, right? So the things that I recommend for upgrade, I do not put in the summary section. My summary is for the how I dictate my summary. The summary is for the client to be able to negotiate with the seller, my buyer to negotiate with the seller on things that were installed correctly when they were originally constructed but have since changed. I don't consider that a negotiable item. And so I do not put that in my summary item. So I don't make a big deal about it, but I do let my client know that that's what I would recommend. Um, all right. Weep screeds and holes. So masonry, stucco, eaves, and other cementations type claddings are not waterproof. Moisture that gets through or that condenses behind the exterior wall covering must be designed to drain through the openings at the bottom of the walls. Deck ledger boards must not block the drainage openings. So if you're looking at a ledger board and are you looking at a deck and then on either side of the deck where there is no deck and you see weep holes, it is likely that the weep holes continue underneath the ledger board. That could potentially be a problem. I mean, I would just pay special attention to the brick up above there. And if you see efflorescence coming through the brick above the deck, a lot of times it's because they blocked the weep holes up. Weep holes for anchored veneers can be made of corrugated plastic to, okay, I think we know what weep holes are. All right. So that's weep holes. All right. Here we're going to get into the fun stuff. All right. So these are some pictures, but I have the actual reports here. So this is a $40,000 deck that had to be completely ripped off. It was trashed. You can see here the picture on the right. So this is why you do not notch 4x4 posts. Uh, you can see how it just cracked right there. Just a little bit of force and that post was done. Even though they actually anchored it to the inside and to an adjacent joist, the 4x4 post, because it was notched, any amount of pressure then ended up cracking through. There's just not enough meat left in that post to be able to provide lateral uh, force support. Again, we were talking about joist hangers and how they need to be, the joists need to be correctly seated. This is just, it's shocking to me that that these contractors tried to get away with what they did. Um, I mean, and you'll see more pictures here in a little bit, but these are some of the most shocking. This post, that joist, and then I know you can't see it, but there is no flashing. There's no ledger flashing. So, yeah, this is a crawl space, and they just directly attached. While they did pull back the siding, they attached the ledger directly to the band joist, and there was no flashing. So, as it rains over time, water is just going to be able to soak in through that band joist, and over time, it'll rot that band joist for the house structure out. Um, and the deck was still kind of under construction, but actually, well, the deck they never put the handrail up in this on this deck, but the homeowner who hired these guys, he ended up taking a lot of the deck apart so that I could get adequate pictures. So I'm going to switch over now to the reports. So let me, I think this is, yep, okay. So here, let me just, well, let me real quick in the chat. I'm just going to put my email so that you guys can have that. Admin at tradexuniversity.org. And oh, that's the wrong. Sorry, I forgot. Hold on a second. Uh, tradexuniversity.org. Okay. Admin at tradexuniversity.org. All right. So now let me change screens here. I'm going to stop sharing and then I'll reshare my next screen. So give me a second. Um, here. Okay. So this, so those pictures that I just showed you come from this report. Um, so my inspection company used to be called A Superior Inspection, but so and not that you'll ever get this deep into a deck inspection on a home inspection. But this is just some good information. So the deck material, the deck boards that they use for the deck floor has a requirement that that the floorboards, because it's a composite deck board, they have a maximum of 16 inch on center between the joists. So this is a screenshot from the installation instructions. So just so you guys are aware, anything, almost 99.9% of anything that is manufactured has installation instructions. Which is oftentimes more stringent than code. So if you come across anything that is manufactured, like instead of using normal, you know, 1x6s for whatever for deck floor, they used a manufactured. I can't. I think maybe there's a picture. I don't know. I can't remember the brand name of it, but it was a composite deck material and it has installation instructions. So those are what I use in my investigations. And so if anything has installation instructions, that's where I go first because, like I said, a lot of times it's more stringent than code. So in this one, it was 16 inch on center. And then here's pictures of the joist being out, being overspanned or, yeah, not overspanned, but being the gap being too wide. And then that was just one example picture. There's many pictures of them being too wide, right? Okay, so um, there's that. The flashing tape. For whatever reason, these guys decided to install horizontal, yeah, blocking in between the joists, I guess, to support. I don't know why they were doing it. Honestly, I really don't. But then they did not install the flashing tape. They only installed, and they didn't even install the correctly sized flashing tape to go over the joists. So that was another call out that that we found. And here, TimberTech Pro. Okay, so that's the manufacturer. So TimberTech Pro is who is requiring flashing tape over the joists, requiring the distance. And here's a screenshot of the manufacturer's installation instructions. Um, Here's where we have no flashing. So you can see that the ledger board is directly attaching to the band joist. Um, And so in the comments that I put in here, uh, it's in Missouri. Missouri is a non-licensed, or is a non-licensed, non-code state if you're outside of city limits. So each AHJ, each city has its own code requirements. The whole state, though, has no code requirements and no contractor licensing requirements. So basically, it's the Wild West in Missouri. And so in Missouri, so in order to try to get this to go to the benefit of my client, we could not use code and we could not use like the contractors like anything contractor related because there was no license required and there was no code to follow. So we had to write this up as it relates to the building material and the installation requirements of the building material. So the building material, so in this report, it's a little different than what I would normally do in a licensed state. But in a non-licensed state, you pretty much can only hold the contractor to the installation instructions. So that's why this is worded as per manufacturer's installation instructions, the deck ledgers had visible flashing, and I did not use a code reference here because code did not relate to this litigation case. So anyway, and then here's our InterNACHI diagram. So I love using diagrams in my reports. I would highly encourage you guys to use diagrams in your reports. Diagrams and reports take away the the when a contractor says, "Oh, it's the code" or "it's his opinion" or whatever. No, if you're able to use a diagram in a report, that shows that another entity that took the time and the energy to create a diagram is who they created this diagram, not me. It's not my opinion. It's fact. It's whatever. It's code. It's fact. So I love using diagrams. And this just kind of goes over that. Uh, so let's see. I was trying to. So the Simpson strong tie. So this is a screenshot from Simpson strong ties installation instructions for joist hangers, and it kind of relates to that picture here where we were talking about joist hangers. Again, I used a InterNACHI. Uh, I used an InterNACHI diagram. Um, And you can see here, so here's the picture that we saw where the joist is not correctly seated, it's not mounted, there's missing mounting hardware because it was cut too short, so on and so forth. And here's where they took joist hangers because they miscalculated, they mismeasured, and they put the joist hanger on and it was too low. They just hammered the bottom of the joist hanger so to get that joist to go up so it was level with the top of the joist or the beam that it was attached to. And you can see they did that on both of those there. That is completely unacceptable and does not meet Simpson strong tie installation or basically any standard. Um, and again, missing mounting hardware, even though they toenail. So even if you see toenails, you still have to install all the correct mounting hardware in the joist hanger. It doesn't matter if they toenail or not. Um, Missing mounting hardware. Again, so as I tell anybody, is that if it's hard for the contractor to get in there, uh, well, if it's hard for you to get in there, it's hard for you to see in there, then it's hard for the contractor to get in there. So the way that they installed these, they they basically blocked themselves in, so they didn't have the tools or the know-how to be able to get a hammer in there or be able to get their mounting hardware in there to be able to put those joist hangers on correctly. So just pay special attention. If it's difficult for you to get there, it's difficult for the contractor to get in there, and that's where you see a lot of issues. Like I said, I have like six different I bought six different sets of diagrams from different companies. CodeCheck is another good one. But here we'll get to some of the pictures. There's another diagram from InterNACHI that I use. Footing diagrams. Okay, so again, they used nails to attach the ledger boards to the band joist. Not acceptable. They cut a 4 by 4 inch post for the safety railing, which is not acceptable. You can see the clear sag in the beam that they did not correctly support in different locations. Here is a beam splice that is unsupported, completely does not meet any standards. Here again, notched a 4 by 4 post. You can see they notched it, they put it in, and then the post extends up to make the safety railing. So there's only what, like an inch and a half, less than an inch and a half of bite on either side of that. So any amount of pressure, that post is going to crack off. Here's more splices that are unsupported. Again, $40,000, man. You'd think that you pay $40,000, you get a quality build, somebody would know what they're doing, but it is very common that they do not. Um, there was no footings, so they dug a hole, put some posts in, and then put dirt back around it. So I don't know if you can see it. Let me see here. Oh, I'm on the wrong thing here. There's actually a gap between that beam and that post. And then they used those precast concrete support piers that are not actual footings, and they just put them directly on top of some gravel. And so this deck, it moved a lot. I mean, there was a lot of, uh, nothing was level, nothing was level, nothing was plumb. There was no supports underneath the stair treads or the stringers. Just again, gravel. So, so that's one report. Let me go to this next one, which this next one is in Arkansas and does have a lot of code stuff going in it. So again, I do mention because these are investigations for litigation, there is a lot of code references. I do not recommend putting any code references in your reports. There is a thing in litigation called setting a precedence. And so when you set the precedence, just like, okay, so you're calling out cosmetic issues or whatever, and you put that in the report, a lawyer can use that against you, saying, oh, you called out this cosmetic defect. Well, why didn't you call out these other cosmetic defect? If you set the precedence that you start calling out cosmetic defects, then it's expected that you continue to call out all cosmetic defects. The same thing goes for code. You put a code reference in your report, you are now a lawyer that who is going to fight against you is going to come at you and tell you that you're a code inspector because you put a code reference in your report. That's why I like to use diagrams. You can use diagrams all day, but stating code or putting a code reference in your report is going to set you up for a nightmare if your case ends up going to court. So just keep that in mind. Um, all right. So before I switch over to this next report, Raymond Zink. So I have overcuts on wood members, first sign of a greenhorn, especially in the carriages. Just get your old time saw out, but that would be my point. Anything I inspect, if I see signs of unprofessionalism, I get serious. Agreed. Um, yeah, I do the same thing, Raymond. The first sign of shoddy work or substandard work, I pay more attention to how things are installed and more attention to defects and so on and so forth. Um, so okay. All right, let me switch over to this other report. Oh, and it's right here. Perfect. And this one we're going to have a lot to talk about. Oh, let me clear my annotations, clear drawings. Oh man, it's giving me a heck of a. Okay, so let's come down here. So, uh, when we were talking about footings being three times the size of the post. So here is a really good example. Now, we do not, we use so when you're talking about footing size, if you actually wanted to dictate how big the footing is going to be, you have to know so much information, which is way out of your scope. You have to know the tributary area and what this, in my area, everything is, I'm in Arkansas, so everything is very minimal. We don't have a snow load really. Our bearing soil is 2,000 PSF. So everything is designed here at 40 snow load or 40 live load and 2,000 for the load bearing of the soils. So if actually, and this arrow is actually is not in the correct location either. But if you wanted to call out footing size, this is the table that you would use to call out the footing size. Again, not recommended that you do the math and you do all of this stuff, but know that the general rule of thumb is going to be three times the size of the post. So they did correctly install 6x6 posts here, but they way undersized the footing. They could put a 10-inch footing in here when it was supposed to be 18 inches. So the issue with this is the amount of pressure on this could start to break this uh, footing apart. Start to crack it, start to chip off. So that's the issue with undersized footings is it's starting to deteriorate prematurely because of the amount the size. These are just the diagrams of acceptable footings, which it did meet the acceptable footing like configuration, just not the correct width. All right. So here's another where we had to pull out we found the installation instructions for the Simpson strong tie joist hangers where they did use screws. Luckily, we still had the screw container on site, and I was able to pull up the manufacturer's requirements for the screws. So these screws are not structural screws. They were just intended to hold down, they're just exterior coated screws that were just supposed to be intended for exterior installation that have no shear rating. So we were able to pull up the installation instructions for both of these screws. And because there were only green star-shaped bits installed in the joist hangers, we knew that that is likely what they installed, but there was no way, and this is actually so I was in court for this specific case last week, and the defendant did pull up. He did bring up in court, hey, there is no way to verify that the screws that were installed in the joist hangers were the screws that came out of these boxes. And in front of the judge, I had to say no, there was no possible way for me to be able to dictate that. But given the evidence, this is what was installed. And luckily, we did find out yesterday that they did file or my client did win the case overall, and he got lawyer's fees on top of it, so that we were super excited about that. Um, and so here's where the LUS face mount joist hanger installation. So LUS face mount joist hanger installation, and this is where it says specifically these are the fasteners that are allowed to be used. Again, you can go above and beyond. If you want to get structural screws that have the shear rating that meet or exceed the fasteners required by Simpson Strong Tie, then you can use those. But these specific screws did not meet those requirements. You can also see in this picture how the bolts are not staggered correctly. They're not spaced correctly. And you'll see that here in a second. Um, So here's another one. Simpson Strong Tie. Use the installation instructions. Use all specified fasteners. See general notes. Joist nails must be driven at an angle through the joist or truss into the header to achieve table loads. So in this one, these are 2-inch screws, which do not meet the 3-inch length requirement. Or here, A minimum of 2.5 inch long nails, or 2.5 inch long SD screws. So these do not meet that because it's a half inch too short. These it does because they're 3 inches. But again, they don't meet anyway. But I'm just saying, we're just talking about the length here. Um, so they did not meet the requirement on there. So this one was a $30,000 deck. And there was a bunch of other issues that I was not called out for. There was painting and other things that I was not called out to document or investigate, but I was just called out for this. So total cost, and they got so this client or this contractor that started this job, one, it went way over. It went 2 months over, and it was a guy. It was a kid. So there's a lot of in my area we are hurting really bad for good contractors, and so basically anybody's starting a contracting business, and this is the results of the need for contractors in my area because our area is growing so fast, and so stuff like this is getting built, and so anyway, so band joist beam bearing did not meet minimum support measurements or mounting requirements. We did not disassemble anything, so I actually don't know how much of this band joist, this two-ply band joist, was actually resting on the support post. I know the back one was probably adequately supported, but I don't believe the front one was adequately supported. But we did not disassemble it to check, and you can see that from this middle picture here. On top of that, the mounting hardware for the beam the beam to support post is, let me see if I can find it. Actually, it's this guy right here. So this is another Simpson strong tie. So it's called the LPZ or LPCZ light post cap. And the key feature is it says it has to be installed in pairs. And you go up here and there's only one installed on each post. So there's supposed to be one on both sides of this post if you were to use the installation instructions for this material in the correct fashion. So you can see there's only one of these per post on each side. So that was incorrect. Here is again what we talked about having the correct, if you're going to make a beam or a girder out of dimensional wood, there has to be specific spacing and mounting requirements, and they did not meet that. So they did not meet the rows. I can't. I don't know if I have the ply. Oh yeah, here it is right here. So here's the deck beams. Beam plies shall be fastened together with two rows of 10D 3 inch by 0.128 inch nails, minimum at 16 inch on center along the edge. And they did not do that. They just randomly shot in a few nails here and there. Does not comply. And look at this. All these joists are structurally mounted to this beam, and this would not fly. And there's going to be eventually there's supposed to be a set of stairs down here too. So in no form or fashion did this meet structural integrity. And you can see how the handrail. So they did notch the 6x6 post. But then they didn't notch it correctly, and nothing was plumb or level, and so they installed these wedges, these homemade wedges, to make the post not flop back and forth. It's just wild. So here's code diagrams where it requires notching, positive support between the beams and the supports, notching here, and they did not do any of this. You can see here, right there, they didn't do any of that. Um, there was no mounting, no connection there at all. Okay, it's not going to let me move down without clearing this stuff. So, all right. So we didn't meet that. All right, here's where they installed wedge anchors in the CMU block. Okay, there's a lot going on in this picture. Not only did they not stagger the bolts in between these, they used wedge anchors in unfilled CMU block. And I don't know, further over here, there was a crack. Now, the client asked me to put the crack in the report, but there was no way to verify that the crack was caused by the builder or by the contractor. So I did not put it in there, but likely it did cause, them putting the wedge anchors in did cause cracking in their block. So this is a walkout basement. So this is a door that goes into a living space. And this is where I was able to pop the ceiling tiles. And this is the sill plate. This is the band joist. Oh, you probably can't. So this is the band joist for the house, sill plate, CMU block, and then the ledger is mounted to the CMU block and not to the band joist because they had to drop it down. So you can actually see the band joist. The siding is over here, so this is the band joist. But anyway, so you look up, and while we all know that you can't use wedge anchors, in a CMU block, um, now that we've taken this class, the installation instructions specifically state not recommended for use in lightweight masonry such as block or brick. So just how vastly important it is to read anything manufactured has installation instructions. Wood is obviously not manufactured because it can be used in multiple different kinds of applications. So there's no way to, hold wood to any type of installation instructions besides code. Whereas manufactured products, you can hold them to the manufacturer's installation instructions. CMU block, we talked about that. All right, and then here's where we get in. So because so I even had to tell the plaintiff or the lawyer that I was involved with that this was an incorrect statement in my report because our code had just changed. Like we just switched when I did this report, the code cycle that had just been put into place was only in place 6 months, and I was going off the old code. So I incorrectly measured, incorrectly put this in the report, which it didn't matter anyway. But so this technically, the bolt sizing being 3/4 of an inch to the bottom of the band joist did meet code. What does not meet is that they overbored these holes. So they overbored and then they did not stagger the bolts. So you can see here uh, the same diagram. Did not stagger the bolts. Here's the 3/4 inch uh, distance that I even had it in the diagram that I did not apply to my comment. But then you get down to here and it says holes for bolts shall be drilled a minimum of 1/32 inch and a maximum 1/16 inch larger than the bolt. So these clearly do not meet that standard. They used washers, which was awesome. But even the size of the holes that they drilled was not even be able to be covered by the washer on this one, and on any of them. You can see this; they're all bad. Um, so bolts. Again, this is a table from the IRC. Uh, you can pull that stuff up. Here's where I specifically call out the installation of wedges for the safety railing that's going to go up there. And then and then this was not this was a side deck. So the deck that we were just on was for the rear deck. This is a side deck. And while I couldn't call out very much in here, they incorrectly used the mounting hardware on these joist hangers, and they cut through the ledger flashing whenever they were, I don't know. Oh gosh, here, let me back that out. So they cut through the ledger flashing. And on top of that, I'm not 100%, but I'm pretty sure this is aluminum flashing. Now, I did not do the measurement, or I did not do the magnet test on it, but but you can clearly see that they damaged the flashing while installing the deck. All right. Um, let's see here. I believe that is the end of this report. Clear drawings. Yeah, okay. So that's the end of that. Let me see here. Will you share the sources of your diagram library? Okay, so I use let me see here. Give me 1 second. Give me 1 second. All right. I have pretty much bought every diagram book that I could. Here, let me go back to my other screen here. All right. So this is one of my Mr. Fix-It Home Systems Illustrated is excellent. I really like it. Code Check is also really good. I love Code Check, Home Systems Illustrated, and then this is probably one of my favorite the Carson Dunlop. Um, their uh, their diagrams are also excellent. So, and then InterNACHI is they're always updating theirs, making them new because as codes change, as standards change, or the diagrams change, and you probably saw there's a few diagrams that I included with code check that are actually out of date. So that those diagrams I used from CodeCheck had the 2 inch minimum to the bottom of the band joist or to the ledger board, and so I should have included, which I had a good diagram in there that did show the 3/4 inch, but I incorrectly put in a CodeCheck diagram. So um, I like InterNACHI's diagrams primarily because like these other companies, they publish them every so often, every couple of years or so. InterNACHI is constantly updating. So you can see on their diagram library that they're adding them to them all the time. So I'm constantly going through and going and checking out their new ones. But those are the four that I primarily use in all my reports. Um, let's see. Great class, great class, great class. Thanks, guys. Thank you, inspectors. I know there's females in here too, so I apologize if I say guys a lot, but inspectors, the royal guys, I guess, is what we're getting to. But I appreciate everyone being here. Thank you for the nice the props and all that. Let's see, where are we at on time? Does anybody have any more questions? We still got about 10 minutes. Uh, Top-notch presentation. I appreciate that. Um, let's see. Think about, is there anything else? Oh, here. While we have this, I will tell you guys, I know you can't see this, but it's incredibly difficult to tell if the wood on the deck is pressure treated. Um, especially if the deck is aged. But so if you want to check, make sure that your clearances are meeting standards versus treated deck versus untreated deck. The really on an older deck, the best you can do is like the tint of the wood. If you can find a stand like if you can find a piece of wood that is also like on the exterior but is high enough that it's not doesn't have to be treated because it's close to the ground, then you can look at the color of that piece of wood and then compare it, and if it's darker, if it's greener, or if it's more blue, then you're pressure treated. If you just have that standard white, very very light yellow wood, most of the time it's not going to be pressure treated. But the only true way to tell if something is pressure treated or not is by the tag. So only if the tag is still installed on the end of the wood grain can you tell if it's pressure treated or not. So just keep that in mind. If you think about calling something like that out, just be very careful when you do. And but if there is a tag on it, then that will tell you for sure. Even the the stamp. A lot of times you can see a stamp. It's a 50-50 shot on if it tells you if it's pressure treated or not. Some lumber yards will put that coded into the stamp. Some will not. Like I said, most of them that we get around here, like this is from Lowe's, and all the Lowe's wood, the only way to tell if it's pressure treated is by the tag.